Okay, so here are the numbers we went through last time. And I'm going to give you a geometric interpretation of the Euclidean algorithm here, which is kind of interesting. So I'm going to say this is a rectangle that's 83 long and 71 tall. Okay, it's probably not drawn perfectly, but I can fit one 71 over here. Okay, and what happens when I make this be 71 here across? What happens to my picture? It's 71 tall since it's a rectangle.
And so this side is 83 minus 71.
Which is?
12.
12. Okay. Now, this is a square now, right?
Yep.
What does this mean? 71 equals 5 times 12 plus 11. What is the geometric interpretation of this going to be?
It means that 5 squares with side length 12 plus 11 more can fit into this picture.
Okay, so maybe what I have to do is maybe make it more like this. I think that'll be a better picture. Okay. So I can just draw 1, 2, 3, 4, 1, 2, 3, 4, 5, and those are supposed to be squares.
Yep.
And these are all 12 by 12 squares, and then what do I have down here?
11.
It's 12.
So you have 12 by 11. So,
Okay.
so 12 by 11,
So it's 12 long
12 long,
and it's 11 tall. Okay, so what happens here?
so then you can fit one square of length 11 into this.
Okay. So now I have one 11 by 11 square there.
Yep.
And then what do I have here?
You have 11, you have a length of 11 by 1.
Okay. So what squares do I fit in here?
1 by 1, so you have 11 of them.
Okay. So I won't be able to draw that in. But what happens is I get this really interesting spiral with squares. So I get a 71 by 71 square, 5 12 by 12s, 1 11 by 11, and then 11 1 by 1s.
Alright.
And so I've chopped my rectangle up into squares.
Alright.
And how many squares were there?
So in total there were 18.
How did you figure that out?
Well, you have the one big one, 5 of these is 6, 7, so you have one small of these and then 11.
Okay.
So 18.
So I had one big one, 5 12 by 12s,
Yep.
1 11 by 11, and 11 what?
1 by 1s.
11 1 by 1s. So the Euclidean algorithm also gives you a very interesting geometric picture of what's going on here.
Yep.
Of chopping up into squares. And are these squares, is it obvious what to do, how to make these squares? Like if I didn't tell you the Euclidean algorithm, I just said chop it up into squares, would you know what to do?
Well, yeah. Yes, because the 71 by 71 square is the largest square that can fit inside this rectangle.
Okay. And what about these 12 by
12
12s?
are the smallest too, and then the 11 by 11 too.
Okay. All right, cool. Now we're going to look at something else. Okay?
Alright.